Hello, everybody. Hi, Ashley. Hi, Pietro. Can you guys hear me? Can you guys hear me? Hey, Ben, can you hear me? All right, we'll get started in about a minute. No problem, Ben. Thank you. Okay, so it's 10 o'clock. We'll get started here. I'm going to share the screen here, and I'll share my desktop. Okay. No, I don't want to do that. All right. Yeah, can I have some indication that you can see my screen?
Yes, Dr. Musgrave, we can see your screen. Oh, wait, no, not yet. Oh, yeah, now I can see it.
Okay, cool. That's great. Okay, what I wanted to do today was focus on modules 3 and 4 and also your test preparation. A lot of people have already taken the test, which is great. But if anybody has any specific questions about modules 3 and 4 as we go, let me know, and we'll go through them. So we're in the test 1 folder here. A lot of people have already gotten a start on what they needed to get a start on, which is good. Some people still need to actually do something, which is unfortunate because, you know, I don't want anybody to run out of time. Thankfully, the stuff in module 1 through 4 is not too bad. It's when we get to modules 5 and 6 that we really start getting some challenges. So I'm glad that you're all here today for this Zoom session, but I think you'll get a lot out of coming to the Zoom session next Monday as well, because we're going to be dealing with some stuff that's a bit harder than what we're dealing with here. So we're going to look at modules 3 and 4 to begin with. And I did do a little bit of this last week. And with module 3, the module 3 assignment, what we're dealing with there is a matching type exercise. And the mechanics behind that is just to be looking at the units mainly, because we've got meters and centimeters here. We know meters have to go on the bottom, so that'll be number 2, and then this will be number 1. So you'll sort the things out in that way. Becomes a bit more challenging when you've got 4 things here though. But again, it's all about making sure the units match. We know that centimeters is going to be on the bottom, so that'll be number 2. What's the linking between centimeters and what's at the end here? Got kilometers. Okay, so we know that kilometers is going to be number 3. And you can see that it's going to be meters and meters for both this 1 and 4. But you need to say, well, what's going to match these up here? And 100 centimeters is 1 meter, so we know that that's going to be number 1. And 1,000 meters is 1 kilometer, so we know that's going to be number 4. Does anybody have any questions so far? Okay. So you'll go through, you'll do the matching exercise for this one pretty much in the same way as I've just done it here. And nobody said they have any questions, so I'll move on to the next part here. Module 3 practice. Now with these, you're actually going to have to write down some things or type in some things. So the idea is that what goes in these will be the conversion factors, what goes in 1 and what goes in 2 here. And the conversion factors, of course, are what's going to be given to you on the test. You don't have to memorize them. And as far as formatting goes, if you're concerned about formatting, all you have to do is submit the quiz without putting anything in. And you'll see exactly what kinds of answers I'm looking for here. Now, I want to point out that if you've got this stuff in parentheses here, these are possible answers. Either one of these is correct, and the answer doesn't include the parentheses, of course. These are just parentheses. So the answer that is being expected for this slot is that answer in that exact format with the space between the G, and you'll know that because you can see it there. Likewise, down here, it's either one of these 2 answers would have been acceptable, not both, and certainly nothing with the parentheses around it. Does anybody have any questions about practice test 3? Okay. The module quiz is pretty much exactly the same formatting as the practice quiz. You get 2 attempts at that. You need to get 80% on the practice quiz to access the credit quiz. Any questions? Okay, module 4. So module 4, the assignment. All of this revolves around the formula that we use for density. Density is mass divided by volume. And you need to focus on things that are going to end up giving you the units that you want at the end. So if you've got, here it says 1.25 kilograms, we know we need something in grams, so the grams per mil cancel. So we know that it's going to be 1 divided by the density here, which would be 2. And then the unused answer, that'll be 3. So you do have to put the unused answer and you just can't leave it blank. So going back to the, well, let me pull up a screen here. There's not much you actually have to memorize for this test, really. I mean, this is something you do have to know because I don't give you this formula. And that is that density equals mass divided by volume. We also know that mass equals, whoops. Mass equals density times volume. And we also know that volume is equal to mass divided by density. And that's what we were doing over here. But if we know the first one, density is mass divided by volume, then everything else follows from that. We just rearrange it to come up with those formulas. So looking at that, this sometimes creates confusion. If you're looking at number 3 here, you can see it's 1 times 2 because it's, well, what's required is mass equals density times volume. And I mean, mathematically, we know that it could be density times volume or volume times density. But you'll notice that in the answers here, I've actually assigned a volume to number 1. So we already know what number 1 is. That means that number 2 must be the density here. And this will be the unused answer. That's a specific gravity. It doesn't have a unit. So you can see that multiplying those two together wouldn't give you the unit you wanted if you didn't have a unit next to the 11.4. So that's how you'll do those. Just make sure you look at this and see what's been assigned when you've got a multiplication like that. Does anybody have any questions so far about the Module 4 assignment here? Okay. When you're dealing with these kinds of problems, these are kind of similar to what you'll be doing on the test, except that here this is a matching problem, and what you're doing in the test will be something where you'll be writing stuff out or typing stuff out. So for something like this, what you're doing is, well, it's 12.4 centimeters on a side. So you know that each of these 1, 2, and 3 are going to be 12.4 centimeters, but you see that they're numbered. That allows you again to distinguish one from the other. So 1, 2, and 3 will be the 12.4. Now 4 will be the product of that. So it'll be 12.4 times 12.4 times 12.4. And you'll notice that it does leave a whole bunch of significant figures here. Now the reason for that is because we're dealing with straight multiplication and division. We don't shorten it down to 3. If we did that, we'd be kind of double rounding. So we choose one of these, and we'll choose this one, number 1 here. And that will be for 4. And you can see in order to get this grams per centimeter cubed, we know that grams will go on top, which will be number 5. And then the second instance of this volume goes on the bottom, so it'll be number 6. And then these two here are unused, so those get 7s next to them. Does anybody have any questions about that? You'll notice that in the end, we get 3 significant figures, 0.0516. The leading zeros aren't significant. Because when we go back to the problem, we can see that we've got something with 4 sig figs and something with 3. So the answer can only contain 3 sig figs. Your answer can contain no more significant figures than the least accurate number, which is the 12.4, because it only has 3. Does anybody have any questions about that? Question 8 is similar. We've got length, width, and height, and it says length, width, and height need to go in that order, so we need to set that up. And you can see how I've got that set up here in the answers as well. But that's very similar to what we just did. Now, number 9, this is where we start getting into things where we need to worry about significant figures, because we've got an addition subtraction problem and division multiplication problem. So looking at this, you can see that we've got a graduated cylinder, 30.0 mils with water in it. And then we add water to it, so we add something to it, and the water goes up to 38.5 mils. So we know that the volume of the object is going to be the difference between these two, and that's going to be 8.5 mils. So we know that that's going to be number 3. And the number 1, of course, will be 38.5, and number 2 will be 30. Number 4 will be the other instance of 8.5 mils. Now you'll notice that when we did that, we went by the number of places past the decimal point. And that's because 38.5 has 1, 30.0 has 1. So the answer comes out to 8.5, which also has 1 significant figure, or 1 decimal, 1 place past the decimal, I should say. Does anybody have any questions about that? We use that figure as number 5, and that actually influences the sig figs we get at the end, because number 4 is the mass, and you can see that that comes out to be 5.7 grams per mil, which would be 2 significant figures. The rest of this here is unused, so we put, well, we put sorry, yeah, 7's next to those. Oh, okay, specific gravity. That's the specific gravity here. Specific gravity is going to be number 6, and that'll be 7 there. So specific gravity goes in here. Now, specific gravity is just really the same thing as the density, except it's divided by 1 gram per mil compared to the density of water. So that's why we end up getting 5.7 without a unit there, and that's what goes in number 6. Does anybody have any questions?
Professor Richard,
Yes, yeah.
you put 2-4 in that question.
Oh, I did? Oh,
Yeah.
so, okay, hang on. Let's see.
Just because the people maybe made mistake, and definitely you cannot repeat the number.
Right, so that should be 5.
Cool.
There we go. Thank you.
You're welcome.
All right, so that goes on the bottom. Yeah, so it's always mass divided by volume. That'll give you the mass divided by volume. That'll give you the density. And you can see even in the unit, it's grams per mil. So it must have been grams divided by mils. Thank you, Anna. Does anybody have any other questions about this? Now, number 10 is a similar problem, except now we're dealing with the density of a liquid, which means we're looking at the 2 masses that we're getting here in the problem. And we know that what the volume is of a liquid is going to be 25.0 mils, but the mass of the liquid is going to be the difference between the flask and the flask, the mass of the flask itself, which is 78.45 grams, and the mass of the flask and the liquid, which is 111.50. So we know that that's going to be number 1 for the 111.50. We know that the 74.85 grams is going to be number 2. And the difference between them is going to be 36.65 grams. So that's when we subtract those two. Again, notice the way that we've handled the significant figures here. This has 2 places past the decimal. This has 2 places past the decimal. So our answer has 2 places past the decimal. So that'll be number 3. The mass goes on top again. So that'll be number 4. And the volume that we have in the question, that's number 5. And that's how we complete the problem there. Does anybody have any questions? All right, so if you can understand all that, then doing the practice assignment or a practice quiz should not be too difficult. And again, you need 80% on the practice quiz to open up the credit quiz. Let's have a look. So the formatting is somewhat similar, except now you have to actually type in the answers. And you actually have to get an answer at the end as well, which has to be correct for significant figures. So let's focus. I think, is everybody okay with the mechanics of doing these problems? Because I just want to focus on the significant figures at the answers. Okay. So if we're looking for density, then, going back to what I was talking about earlier, we know that it's density is mass divided by volume, and that's how it's set up here. So we know it's mass divided by volume. That'll give us the answer. And when we're putting in the answers, it's just going to be exactly what we have there. 25 mils. Oops. 25 mils goes in here. And then we have the answer here. We calculate it out. Now, looking at the significant figures here, we've got 50.00, which is 4 significant figures. We've got 25, which is 2. So the answer comes out to 2 significant figures, which is 2.0. And the unit there would be grams per mil. And again, note what we did here, grams divided by mils, grams per mil. So it makes sense that that would be the unit there. Does anybody have any questions about this? Question 2 is somewhat similar, so I'll skip over that. This one, though, I want to go into in some detail. So we're looking at the difference here between 28 and 18. So we know that that's what goes in 1 and 2. So it's going to be 28 mils and 18 mils. So we're looking for the difference between these, and because we're dealing with addition and subtraction, we're looking at the number of places past the decimal. So we know that there's going to be no places past the decimal here, no places past the decimal here. So the answer comes out to no places past the decimal. But the answer is 10 dot mils, not just 10 mils. Now I do go into that. Actually, what I'm going to do is I'm going to pull up, hang on. I'm going to pull up another instance of my courses here so I can show you something. Because that's often a real sticking point for people is this, well, hang on, what's the difference between 10 and 10 dot? I put that in my calculator, it comes out as 10. Why isn't that correct? It's a fair question, fair question. But what it comes down to is accuracy. And I have this video here that explains the difference between 10 dot and 10 mils. And I really would encourage you to watch that because it does go into the exact reasons why that's important. But the short story is here that if you have 10 dot mils, that really does represent a number somewhere between, that could have been rounded between 10.4 and 9.5, whereas 10 without the dot is a number that's really lies somewhere between 5 and 14. So asking yourself the question, which do you think is reflective of the accuracy? Something between 10.4 and 9.5 or something between 5 and 14? I hope you would come up with 10 dot as being more accurate than 10, than 10. Does anybody have any questions? In number 4, we put the mass, and you'll notice when I put the mass in, and this is important, I take it directly from the question. Often I'll see people do this. I say, oh, 10.00 grams, oh, that's just 10 grams. I'll often see people do that. That's not the same number. For the same reason as 10 dot is not the same as 10.10 without the dot. So we know that the volume here is going to be 10 mils again with the dot on it though, 10 dot. Then when we divide these, we've got 4 sig figs divided by 2 sig figs. So our answer comes out to be 2 sig figs, which is why it's 1.0 grams per mil. So that's a bit tricky. So make sure you understand everything I just talked about there. And if you don't, now's a good time to answer. So now's a good time to ask questions about that. Does anybody have any questions? All right. So it's going to be the same kind of deal on this one here. I will go through it because I want you to see the significant figures here. We've got two masses, 26.00 grams, 36.00 grams. We're going to subtract those, so we'll do 36.00. Notice that I just take the whole number as it is in the question. I don't shorten it down to 36 or 26. And then when we do the subtraction here, we're looking again at number of places past the decimal. So that would be 2 places past the decimal, 2 places past the decimal. 10.00 grams is what I get on the mass there. Not because there's 4 sig figs, but because there's 2 places past the decimal. And we're dealing with subtraction there. Any questions? Number 4, that's going to be that same mass. And then the volume we're given in the problem, 20.0 mils. Again, making sure that we include the whole number. And then we can look at the density, which would be the the division of those two, which would be 10.00 divided by 20.00. And whatever we're getting here has to end up being 4 significant figures, because that's 4 sig figs, that's 4 sig figs. So we end up getting 0.5000 grams per mil. Does anybody have any questions? Any questions? I mean, that could be confusing because we're dealing with 2 different sets of significant figure rules there. We're dealing with addition subtraction, which uses places past the decimal, and then we're using significant figures because we're doing a division at the end there to get the density. All right, no questions? Okay. So that's really what I had wanted to go through, at least as far as the homework goes, the Module 3, the Module 4 homework, the assignments. The other thing we will look at here is one other thing that you will be required to do for Module 3, which is the significant figures quiz. Okay, so you'll find that at the bottom here. And this is the qualifying quiz. You need 100% on this. And I did go through this. I did go through this in the last Zoom meeting, so I won't go through it again. If you want to see my treatment of this in the previous Zoom meeting, I'd ask you to go back and look at that. But does anybody have any questions about this significant figure quiz that they want to ask here? Okay, well, don't forget to do that. The other tip I have for you at this point is if you're concerned about having missed something, or you don't know what you need to do for homework and that kind of thing, actually, let me view as a student here. Go to the grades area here, and you'll see everything that needs to be done for test 1, and they each have T1 next to them. So if you have any scores of 0 here, that's probably an indication you haven't done anything, you haven't done what you needed to do yet for that. So that would be that would be my go-to. That's how you'd know, for example, that you needed to do this significant figures quiz. That would be your tip-off. Does anybody have any questions? All right, so that's mainly what I had wanted to go over for modules 3 and 4. I'd like to now focus on the test, the practice test. And for practice test, you'll find in the test 1 portion of the table of contents. And what I'm talking about here is practice test 1. Under that, you'll see there's test 1. Now you get 2 attempts at test 1. That's what will actually give you your grade. But it's important to note that test 1 and practice test 1 are exactly the same test. Meaning, because practice test 1 can be taken unlimited times, if you take that unlimited times, or you take it as many times as you need to be comfortable with it, and then you're taking it under the same conditions under which you're taking test 1, it's difficult for me to see how anybody can fail test 1 if they've taken practice test 1 under test conditions sufficient numbers of times. The same questions will be in test 1 as are in practice test 1, except that sometimes the numbers change. The other thing that's important is this study guide here, which tells you the possible kinds of questions you can see for practice test 1. So when you see something like this, where it says number 1 is electron diagrams for atoms, well, that's all that's possible for number 1. For number 2, expected charge of iron. That's all there is expected there as well. But for number 3, you can see there's possibilities. You could have something about group, period, valence electrons, periodic table region, or relative sizes of atoms. Any one of those could pop up in your test. However, it's always the same questions. So if you were to take that practice test sufficient times, I think you'd begin to see repeats on the questions. Yeah, but, it's the same test in test 1. So again, you could possibly see repeats there as well. But that's why it's important to take practice test 1 a number of times. So you get to see all of these different possibilities and answer those questions as well. So you're prepared once you see test 1. I'm trying to be as transparent here as possible. I'm not trying to be tricky. I'm not trying to hide anything from you. You'll know exactly what you're expecting here. Does anybody have any questions about the formatting so far? All right, let's take a look at practice test 1. As I said, it's going to go pretty much by what we saw. I've got to move this over here. Okay, I'm going to just check the chat here and just make sure. All right. Okay, there we go. Yes, there is a question here. Will the test have conversion charts and Prereq table? The answer is yes. Take a quiz. Take a look. So we're in practice test 1 here. And the real test has the same formatting. So therefore the same stuff. So what do we see? We see a Prereq table. Okay, so you say, oh gosh, I have trouble reading some of those numbers. What can you do about it? Well, you can always increase the size of your screen by using Command plus or Control plus, depending on what kind of computer you're on. Take a look at that, look at that, look at that, look at that. So even if you have trouble reading those numbers, you can always do that. And you could shrink the screen by using Command minus or Control minus, depending on the computer you're on. All right, any questions? I don't think you'll need the numbers anyway for practice test 1. You might later for practice test 3, for example, if you're looking for molecular weights and things, but certainly not for what we're doing here.
Dr. Musgrave?
Yeah, yes.
I believe when I was looking at the practice test, one of the questions were to arrange from largest to smallest.
Mm.
And I did not, I kind of memorized it because I've seen it so many times, but I didn't see that in one of the charts. Are we going to be able to, is that something we should just memorize? Or will that be in there?
No, that's something for which, that's something for which you need to be aware of a trend.
Okay, okay.
So let me show you where that is so that you can look
it's in the survival. I know mine is in my survival guide that I bought.
But it's in module 2 specifically. Let me show you exactly where it is so you can go look at that again.
Yes, sir.
So there's actually 3 trends you're going to have to be aware of here, but that's why you've got the periodic table as well. See, this is where you're talking about size, which is atomic radius. Maybe that was a disconnect. You weren't aware that atomic radius and size were the same thing, but that's and you can see the trend there. Atomic radius decreases across the row, and also decreases going from here to from the largest, which is francium, up to the smallest, which is hydrogen. And you can see there by comparing them, whichever one's closest to FR, that'll be the largest. Whichever one's closest to helium, that'll be the smallest. So it really just becomes a matter of knowing those trends and what's the most and least of each. This is ionization energy on the previous page, and on the page previous to that, you've got electronegativity. So those are the 3 possibilities that you can get there for that specific question.
Okay, thank you.
All right, so looking at the test here, you know, when you diagram an atom of magnesium, you have, and we talked about this last week. I'm going to go through the test here. I'll do a complete run through for you because I know that's why you're here today. You want to be able to see what's going on. Let me shrink this a little bit here so that we can have a screen here. All right. So when you're looking at magnesium, you will have to go back, take a look at the periodic table, and you say, okay, magnesium, that has 12 protons. That means it also has 12 electrons. So we go through and we look at that. You will be able to have a sheet of scrap paper next to you so that you can do this kind of stuff. So you'll have the nucleus there, which has 12 protons in it. And then we have one row, we have a second row, and we have a third row here. On the first row, we're going to have 2 electrons. And this is going to be mirrored by the fact that we have 2 elements up here. I know the hydrogen's twice, but really essentially it's hydrogen and helium. So there's really just the 2 elements here. So that's why we've got 2 electrons in the first row. If you count the second row, we've got 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be 8 electrons in the second row. And we've used up 10, which means we've got 2 electrons left. And you can see that even on the periodic table, we get 1, 2. So we expect 2 electrons in that third row. So what I would do is I'd do 2, 8, and 2. And of course, everything here has to add up to whatever the atomic number of magnesium was, which is 12. So we got 2 plus 8 plus 2 is 12. Does anybody have any questions about number 1? Okay. The next one is going to ask about valence electrons. It'll give you a valence electron, and then it'll ask you about the charge of the ion. So what you would do for something like that since you don't even have to figure out how many, what's going on here? Since you don't even have to figure out how many valence electrons there are because you're told how many there are. So the situation is like this. We've got a nucleus, and for lithium, you wouldn't have to do this, but the situation is it's got 1 valence electron. And the question you're asking is, well, what's lithium going to do in order to be more stable? Well, the things are more stable when they have full shells of electrons. So in order to obtain a full shell of electrons, this could either lose 1 electron or it could gain 7. It's far more likely to lose 1 electron. And if you lose an electron, what happens is the lithium will go from lithium to lithium plus. Now, the reason for that is that in the middle, we have 3 protons. And on the outside here, we have 3 electrons, which goes to 2 electrons if we take one of them away. If we take the net of those, or we add them together, we've got 3 minus 2, which is going to equal +1. So that's where we're getting the +1 charge from on the lithium. You can go back and take a look at module 2. That's one of the more difficult concepts of module 1. One of the more difficult concepts of module 1 is figuring out figure out what charge we get on ions. Does anybody, excuse me, does anybody have any questions about that? So let's say it was 6 valence electrons. In that case, what you'd want to do is come up with adding electrons to that to get 8. You need 2 electrons. The charge then would be -2 in that instance. So taking away electrons always leads to a positive charge, and adding electrons always leads to a negative charge. Does anybody have any questions about number 2? Okay. Question 3, if you go back to the study guide, you'll notice that there's lots of different possibilities for this. There's groupings, there's valence electrons, there's areas of the periodic table, all sorts of other things that can go here. This one is about grouping. And when I say grouping, I'm talking about what group is potassium in. And by grouping, it's columns. So this one would be in column 1, group 1. So that would be your answer there. Does anybody have any questions? Oh, it does say which grouping. Okay, so that would be, in this case, you'd have to know the area. That would be alkali metals. That is group 1. That's in, I think it's in module 2. Let's take a look. There we go. Yeah, so regions of the periodic table, and then these are the regions here. So you would have to know these. Alkali metals, alkaline earth metals, transition metals, non-metals, halogens, and noble gases. Does anybody have any questions about that? So that's in module 2. Okay. So for this one, I did get a question from a student about this one the other day. They didn't know where these numbers came from. Well, these numbers are called Pauling electronegativity numbers. They're based on a scale called the Pauling scale. I'll try and pull it up here online. And I don't require that you know this or know these numbers or memorize them, but they're on a table, and you can access these pretty much anywhere on the internet. There's lots of different places, but these are numbers, and you can see that the fluorine, it's essentially assigned a value of 4. It's got 3.98 here, but it's assigned essentially a value of 4.0, and then everything is relative to that. That's the most electronegative element. Then you can notice that there's a trend here. It increases across, and also, decreases going down. But these numbers here will influence the kind of bonding that we're going to be dealing with when we're looking at two elements. So just on a very brief basis here, I'll go over what we're talking about with that. But that's where those numbers come from, that scale. We got here P and Cl, and we know that a bond between them is going to consist of 2 electrons. We also know that when we're looking at P and Cl, not that we really have to be aware of this, but P and Cl, Cl would be more electronegative than P because it's closer to the fluorine. But we also know that from the scale as well. You can see that P is 2.2 and Cl is 3.2. So that's clear as well. But I know that the 2 electrons will be somewhere in between the P and the Cl, but closer to the Cl. That's what I get from that so far. Now, the kind of bonding that we're talking about, in this case, is going to be polar covalent. So the 3 kinds of bonding we're talking about, polar covalent, nonpolar covalent, and ionic. And what I like to do is just look at the periodic table to figure out what I'm going to get there. You see P and Cl are fairly close together, but they're not the same. So that's why I say it's polar covalent. If it was 2, let's say it was 2 Cls, I'd know that the electrons were smack dab in between. That'd be polar cov. This would be nonpolar covalent. And if it was Ba and Cl, I'd know that the electrons were on the Cl because there's a large difference in distance between them on the periodic table. So Ba is down here, Cl's over here. And I know that if I've got a really large distance between them, we've got metals and nonmetals, we're talking about ionic in that case. So it's actually a situation now where the electrons are actually on the Cl, and this would be Ba2+. And there'd be Cl- and Cl-. So ions, charged particles. That's why it's called ionic. All right. Does anybody have any questions about number 4? Any questions about number 4? All right, Ashley, you were talking about question 5. Now, question 5 has 3 possibilities. That was the electronegativity, ionization energy, and size. It could be any one of those. That's why it's important to take this practice test a number of times so you get to see all the different possibilities. What we know about ionization energy is that ionization energy is the energy required to remove an electron from an element. And it's going to be smallest for something like francium and highest for something like helium. So if I've got these 3 elements here, I've got K, Br, and Cu. I find them on the periodic table. I've got K over here, I've got Br over here, and Cu over here. They're in the same row. I'd know that K would be the least and Br would be the most. Then I look at the question and it's looking for highest to lowest. So the highest is number 1, that's going to be the Br. And the lowest is going to be the potassium, that's going to be number 3. Of course, that makes copper number 2. So it's important there in a question like that to make sure you understand and see the 1 and the 3 and know exactly what order you're supposed to put these in. Does anybody have any questions about that? About number 5?
No, that's very clear. Thank you.
Okay, let's take a look at the conversion sheet here. You'll see is actually in a test. You don't have to hunt it down. So it's given to you. So what you will do there is the same thing as what you've been doing in the practice, module practice, and the credit quiz. So for something like this, I've got 31 pounds and I need to figure out how to get to kilograms. So I know that number one is going to have to be kilograms. Maybe it's a good idea just to put the units in first, so you know what you're dealing with. And I know that pounds will go on the bottom to cancel. So I know I'm looking back on the thing up here for something with kilograms and pounds. So I look over here. I think I'm dealing with mass. Oh, there we go, kilograms and pounds. So 1 kilogram. And when I'm putting into pounds, I do have to type in the whole thing. I know it's a bit of an annoyance, but that's why you've got scratch paper there as well. And I try and keep with the formatting that I've learned about as well by doing the other quizzes, putting a space in between the number and the unit. Then I would do the calculation, put it in my calculator, 31 divided by 2.204622,622, the whole thing. And I come out with, in my calculator, 14.061364,347. Now, I'm not going to put all those figures in here. What I do is I go back and I look at the problem. I see I've got 2 sig figs here. So my answer contains 2 sig figs. So I'm going to put in 14 and space, then LB. Does anybody have any questions about number 6 or the mechanics of what I just did there? Okay. Number 7, similar kind of question. Obviously, be different to number 6. And there we're looking for meters and we're given kilometers. Okay, so we know that kilometers goes on the bottom. So I'll go ahead and put unit in there. Put meters on top. And I also know that what I'm looking for has meters as well. So you can see that, I think you can see the value there of putting in the units first. It really does set the scene for you and stops you from getting mixed up. Stops you from getting mixed up. All right, so let's have a look. Meters and kilometers. So I go back to the thing here. Okay, meters and kilometers. There it is. 1 kilometer is 1,000 meters. And when I put this in the calculator, I can see that it's going to be 0.00135 times 1,000. And it comes out to be 1.35, which actually has the correct number of significant figures. So that's 3 sig figs, that's 3 sig figs, so our answer must be correct. That can't be right. Oh, no, it is right. That's all right. That's good. All right, does anybody have any questions? Okay, something like number 8 becomes a little bit more challenging. But again, I think by putting the units in, we can sort ourselves out a little bit more easily. So something like this, we know that number 2 is going to be feet, so it has to cancel. We know that number 3 has to be meters because that's what we want at the end. So what we need to do here is find the linking unit between feet and meters, and we'll get that from the conversion chart. All right, so I'm looking here at the lengths. I actually only have one thing here for feet, and there it is. 1 foot is 12 inches. So I know automatically that inches is going to be that unit, but I need something to go from meters and inches, and there is something here as well. So I know that what goes in here, this will be inches for number 1 and inches for number 4 as well, because you can see that whatever we get here, 1 has to be a unit, 4 has to be the same unit. So once I figure that out, I know that these have to be the same. Does anybody have any questions so far? So now we need something to go from inches and feet, and we know that it's 12 and 1 of that conversion chart. And the other one was 1 meter and, let's see, 39.7. I'll just check on that, make sure it's correct. So it has to be exactly the same, yep, and it's right. So then I can do the math here on this, and let's see, so it'll be 12, I'll do 123.0 times 12. And it looks like it's divided by 39.370. Okay, and I end up getting 37.490399 meters. We got 4 significant figures here, so we need 4 significant figures in the answer. So that's how I get 37.49 meters. Does anybody have any questions?
No, that's a good trick to kind of keep yourself in order.
Yeah. I'm full of good tricks. Okay. So this one here, we're going from inches to millimeters. So I know that number 2 is going to be inches. I also know that number 3 is going to be millimeters. So what we want at the end. So now we're looking for that link between inches and millimeters. And I can see that for inches, we do have a link to centimeters, and for millimeters, no, we don't have a link from millimeters to centimeters, not on here, or do we? We do. Actually, I'm lying, we do have it. Sorry, it's not, it's just here, I think. 1 centimeter is 10 millimeters, it's coming up, there it is. So there might be a couple of ways actually of getting to the answer. There's you might be able to do it through inches, or you might be able to do it through centimeters. But either one of those will be right, and it will be marked as correct because I've got both sets of answers in the thing as well. I mean, when you go ahead and do it, you'll get that right answer. So we'll do centimeters, and we know that for centimeters to inches, it's going to be 2.54 centimeters and 1 inch. We've got 10 millimeters and 1 centimeter. And then we can go ahead and do the math on that. And it'll be 0.156 times 2.54 times 10. And it comes out to be, well, we got 0.156, that's 3 sig figs. So we need 3 sig figs here, so it'll be 3.96. Even though it comes out to 3.9624 in the calculator. 3.96, and the unit here is millimeters. Does anybody have any questions? Okay. Now for this one, the temperature conversion, you do have the temperature conversion numbers over here in the actual chart that you're given. So you don't have to memorize any of that. There it is. In this case, we're going from degrees Fahrenheit into Kelvin. In order to do that, I'm actually going to have to convert into Celsius first, and then go to Kelvin from Celsius after I get Celsius. So I have to do a little bit of math here. but I do have the equation, so it's not too difficult. So I'm looking for Celsius here off Fahrenheit, and one of I'm looking at the two equations here. I don't think that this one is entirely helpful to me because that gives me Fahrenheit. I'm actually going to have to work with this one a little bit. 5F minus 9C equals 160. And what I'm looking for, 9C, what I'm looking for here is Celsius. So the way I can get that is I can do 160 minus 5F divided by well, so let's rearrange that a little bit more here. Yeah, so we'll do 5F minus 160 equals 9C, which means that C is equal to 5F minus 160, and that's all divided by 9. So what we'll do then is we can sub in that for the Fahrenheit there, whatever we're starting with here in the problem, which is going to be 56. So it'll be 56 times 5 minus 160, and that gives us 120 divided by 9, which comes out to 13. I'm going to just put in as many sig figs as I have here, just because what we're doing. And I'll tell you how to get the sig figs at the end. It's kind of important that we get to that part in a second. Then I take this and I add 273.15 to it. And it's multiple choice. So you're just trying to get something close so you can pick out the right answer. And it comes out to be 286.48. Kelvin. But we need the right answer here. And what we do is this, because this is I know it looks like a multiplication division problem, but it's actually an addition subtraction problem. And the reason for that is because 5 and 9 here are counting numbers. 5F is actually not really 5 times F. It's actually for F plus F plus F plus F plus F plus F. So it's F added to itself 5 times, which means it is an addition subtraction problem. Which means that all you do is you look at the number here and you ask yourself, well, how many places are past the decimal? And the answer is none. So I'm looking for the closest answer to that matches, and that would be 286. That's what I would put in there. So just look at the number of places past the decimal. That's all you do. None, none. Any questions? Okay. So 11 is about a density problem, and this one relates to, and I think you'll find that all the question 11s are very similar to this, and it deals with volumes and masses. So number 1 is finding the difference in that volume, which is going to be 37.8 ml. And then we've got $15.3. And what we're looking for here is the distance, the difference in these volumes. Which comes out to be 22.5. And I do have to write significant figures here because it goes by number of places past the decimal. So that's one place. So that comes out to be one place. Any questions about that? Now we're told what the mass is. It's 35 grams. So we just put that in directly. So that's for number 4. And we use the same volume as we came up with as the answer there. And then we come out with our answer. So it's going to be 35 divided by 22.5. And we get 1.55555 in the calculator, but we need two significant figures because we've got 35 and we've got 22.5. So that goes 2 sig figs, 3 sig figs. So the answer comes out to be 2 sig figs, which is going to be 1.6 grams per mil. All right, any questions about that? Okay. And for this one, we've got a cube problem here. So we know that what goes in each of these, we're going to have to figure out the volume of this cube, which is going to be side times side times side. So it's going to be 2.0 centimeters. Now, note that I can't just put 2 centimeters in there. 2 and 2.0 are two different numbers. So that'll give me that. Now, in number 4, I want to have at least the right number of significant figures. So 2 times 2 times 2 is 8, but I just don't want to put 8 there. I want to put as many sig figs as I'm dealing with up to that point. If it happens, the thing is that I could always come back and look at your test if you want me to. If you've put more sig figs in here than are needed, I can deal with that. What I can't deal with is less sig figs than what you're dealing with. So that would be 8.0 that goes in here. Then we've got the mass, that's 78.00 grams. Notice again, I put in the entire number. Then we've got our 8.0 cm cubed. Let's put the right unit in there. Oh, that was a mistake. That would have been marked off. So then we do our subtraction here. Comes out to be 9.75, but that has 2 significant figures, and that comes from the 2 sig figs up here in each of these. So that has 2 sig figs. So the answer comes out to be 2 sig figs as well. So that would be 9.8. And the unit is going to be grams divided by cm3, because that's what we came up with here for our volume. Does anybody have any questions?
Yes, can you just say that last part again about why it becomes 2 sig figs?
Right, because it's all multiplication division. What I do is I look up here at the problem. I see if this has 2 sig figs, my answer can contain no more than 2 sig figs.
Okay.
Just always look at the problem to see the smaller sig figs. That'll tell you exactly how many you need in your answer.
Okay, perfect. Thank you.
Now, keep in mind, that's only for this kind of problem that is straight multiplication division. For this kind of problem, we do have to sort out, well, what sig figs do we get here? And then apply that down here. It's different because this is addition subtraction and this is all multiplication division. That's why there is a distinction between these two. It causes students no end of pain. Does anybody have any questions about that? There's a real distinction between those two problems. Well, that's the whole test, folks. That's it. So it's not too bad. I think you'll manage it. There's a lot of detail. Let's see. I've got 2 hours there. How long did it take me? And this was with me explaining everything. It took me 30 minutes. Do you really think you're going to have trouble with time? I don't think so. Does anybody have any questions? So if you're nervous about it, what do? Just do that practice test again and again. Do it until you're feeling it. Do it until you say, you know, I know this so well, I'm sick of it. That's what I would do if it was me. And I would do it under test conditions. Do it under the same conditions under which you're doing the test, and you should be fine. Just do it multiple times. I don't see why anybody should fail. I really don't. Okay, any questions? Anything at all?
I'm good. Thank you so much.
All right. Well, we'll leave it there for today then, folks. I'm not going to go through anything related to test 2 because I know the students hate doing that. you haven't completed the test yet, let's not get on to the new material yet. But I will just remind you that the due dates did change for Module 5. I did make them a week earlier just for Module 5. So Module 5 will be due next Tuesday at 11:59 p.m. And there will be a Zoom meeting on Monday when I'll be going over that. So during this week, I'm expecting people to go over the Module 5 stuff themselves, have come up with questions, and then you can ask me at the Zoom meeting on Monday. But you can also email me during the week if there's any problems that you're having with Module 5 too. All right, so we'll leave it there for today. Thanks very much for coming, folks, and good luck. And I'll see you later.
Thank you, Professor Richard. Have a great day.
Thank you.
Right, bye.
Bye.